Here's another problem for us with one method of a procedure called acceptance sampling. A sample of items is randomly selected without replacement, and the entire batch is accepted if every item in the sample is okay. Company just manufactured 1,644 CDs, 761 are defective. If 8 of those CDs are randomly selected for testing, what is the probability that the entire batch will be accepted? So let's see how we can approach this problem. We have information about the total and number of defectives, so we can find out the probability if out of all those total we select a defective CD. So let's call this a probability of D. D is in defective, and this would be 761 divided by 1644. Now, we're interested in sampling 8 of these CDs to make sure that they're okay. So let's find the probability that CD is okay, and if it's defective, it's not okay. If it's not defective, then it is okay. So okay means D complement. And the complement is going to be 1 minus the probability that it is defective. So if we do 1 minus 761, we should get, if we subtract 1644 from, or 761 from 1644, we should get 883 over 1644, and this is our probability that it's not defective. Now we're going to pull 8 CDs out of 1,644, and just to verify, if that is less than 5%, then we can treat this as if this was done without replacement or with replacement. So let's take 8 divided by 1644, and this is less than 1%, so it's less than 5%. So we'll make a note that 6 divided by, or 8 divided by 1644 is less than 5%. So we can treat this as if this is a probability that we're getting 8 CDs with replacement. Alright, so what we're interested in is we pull out 1 CD, and that has a probability of 883 over 1644. So without replacement, or with replacement, we imagine we put that back, we pull out a second CD, and the probability that that will be accepted is again 883 over 1644. And then so we'll do this 8 times, and what we have here is essentially the multiplication rule applied to our problem 8 times. So if we just figure out what 883 divided by 1644 is equal to, we can multiply this 8 times. That is the same thing as taking it to the power of 8. So that little caret button and 8 tells you you're going to multiply this 8 times. And so that probability is 0.0069. And we're looking to fill this in. Let's take a look at how they want us to fill in the problem. Around to the nearest thousandths. So thousandths, that would be the tenths, hundredths, and thousands, 3 decimal places. So we want 0.007. And there it goes.